It was 1977. While disco ruled the dance floor, NASA looked up and launched Voyager 1 and Voyager 2. These weren't just satellites. They were our emissaries to the cosmos, set to explore Jupiter, Saturn, Uranus, and Neptune in a rare planetary alignment. Built with less computing power than a modern phone, they were aimed at moving targets billions of miles away on a one-way trip into the unknown. Each carried a golden record, a message in a bottle for any distant civilization. The Voyagers were more than science. They were a testament to our curiosity and hope. They sent back breathtaking images: Jupiter's great red spot, Saturn's shimmering rings, Uranus's tilt, Neptune's deep blue storms. Every postcard rewrote our textbooks and expanded our cosmic perspective. After their planetary flybys, the Voyagers kept going, heading for the edge of the sun's influence. They were bound for the boundary where our solar system ends and interstellar space begins. What would they find there? An empty void, or something unexpected? The twin spacecraft, aging but still reporting back, were about to send us their most astonishing message yet. A message from the very frontier of our cosmic home. Their journey was a statement. We are explorers, always reaching for the unknown. The world watched as these tiny probes ventured farther than any before. Decades later, their signals still whisper across the void, carrying our story. The Voyagers became the eyes of a generation, and their journey continues. They remind us that even the smallest emissaries can make the biggest discoveries. And at the edge of everything we know, they found something that would change our understanding of the universe. Imagine driving for days, then suddenly crossing an invisible line where the air outside blazes hotter than the sun's surface. That's what happened to Voyager. It encountered a seething, invisible barrier at the edge of our solar system. The temperature spiked to 90,000 degrees Fahrenheit, 10 times hotter than the sun's surface. Scientists called it a wall of fire, not just for drama, but for the sheer extremity of this cosmic frontier. Most expected a gradual fade into interstellar space, but this was a sharp, superheated boundary. Our solar system, it turns out, is wrapped in a fiery shell, separating us from the rest of the galaxy. This wall is where the wind from our sun collides with the winds of other stars, a cosmic battlefront billions of years old. Understanding this boundary is crucial. It shapes our environment and shields us from harsh galactic radiation. Voyager's discovery was a profound reminder. The universe is always stranger than we imagine. This wall wasn't in the mission plan or the textbooks. It was waiting to be found. Thanks to Voyager, we now know the edge of our home is not a quiet shore, but a roaring, fiery crucible. The discovery sent shockwaves through science, forcing us to rethink our place in the galaxy. The Wall of Fire is a dynamic, ever-changing frontier. It's a cosmic gatekeeper, defining the true border of our solar system. And it's only the beginning of what lies beyond. The Wall of Fire Voyager found is called the heliopause, the true border of our solar system. To understand it, picture the solar wind, a stream of charged particles from the sun racing outward at over 1,000,000 miles per hour. This wind creates a vast bubble, the heliosphere, that shields us from the harshness of interstellar space. But the bubble isn't infinite. Far beyond Neptune, the solar wind weakens, meeting the interstellar wind from other stars. The heliopause is where these forces balance, a cosmic standoff. Imagine two rivers colliding, the solar wind flowing out, the interstellar wind pushing in. The meeting point is chaotic and turbulent. This invisible shield is vital for life on Earth, deflecting dangerous cosmic rays from deep space. The heliosphere's edge, the heliopause, acts as our solar system's deflector shield. Without it, high-energy particles from supernovas could threaten life as we know it. Voyager's crossing revealed just how dynamic and protective this boundary is. It's not a solid wall, but a shifting region of immense energy. The heliopause marks the end of the sun's domain and the start of the Milky Way's vast ocean. This distant boundary plays a direct role in making Earth habitable. Voyager's journey showed us our solar system is not isolated, but actively interacting with the galaxy. The heliopause is our invisible shield, quietly guarding our cosmic neighborhood, and now for the first time, we've seen what lies beyond. Why is the edge of our solar system so hot? The answer lies in a cosmic collision. The interstellar medium isn't empty, it's a thin soup of hydrogen atoms. As our solar system plows through this medium, neutral atoms drift across the heliopause and into the heliosphere. The sun's ultraviolet light ionizes them, turning them into charged particles. These ions get swept up by the solar wind, but as the wind slows near the heliopause, a cosmic traffic jam forms. The sudden deceleration compresses and heats the particles, like air heating up in a bicycle pump. The result? A superheated plasma, the wall of fire Voyager detected. There's no flame, just particles moving at incredible speeds, measured as temperature. This region, the inner heliosheath, is a turbulent, energetic plasma. It's a natural consequence of our solar system moving through the galaxy. The wall of fire is a testament to the immense energies at play on the galactic frontier, and it's a reminder that even the emptiest parts of space can burn with invisible heat. How did Voyager detect this heat? Not with a mercury thermometer, but with its Plasma Science Experiment, PLS. The PLS measures the energy, speed, and temperature of charged particles. As Voyager 1 neared the heliopause in 2012, the PLS recorded particles moving slower but much hotter than before. This was the first clue Voyager was entering a new region. Other instruments detected a stronger magnetic field, confirming the crossing. Voyager 2, following a different path, confirmed these findings in 2018. Two spacecraft, two crossings, proof that the wall of fire is a persistent global feature. Without Voyager, we'd never have known this cosmic furnace surrounds our solar system. If Voyager flew through a 90,000-degree region, why didn't it melt? The answer: temperature isn't the same as heat. It's about particle speed, not total energy. The wall of fire is like the air in a hot oven, very hot, but not dense. There are so few particles that almost no heat is transferred to the spacecraft. Even at extreme temperatures, the near-perfect vacuum means Voyager feels nothing. It's a cosmic paradox. You can fly through a wall of fire and not even notice. This concept is crucial for understanding space extreme temperatures, but almost no matter. Voyager's survival is a beautiful demonstration of physics on a cosmic scale. The universe is full of places like this, hot, empty, and mysterious. And Voyager proved we can cross them. The discovery of the heliopause's fiery wall changes how we plan for interstellar travel. Any future starship must cross this turbulent, superheated magnetic boundary. Understanding its physics is key to designing spacecraft that can survive the crossing. This knowledge will shape the next generation of interstellar probes. Engineers must shield electronics from both cosmic rays and the unique plasma of the heliosheath. We may even design missions to linger in this region, studying how our solar system interacts with the galaxy. The wall of fire is now a known challenge, not a mystery. It also helps us search for life. Other stars likely have their own protective bubbles. A strong astrosphere could make planets habitable by shielding them from galactic radiation. Voyager's findings are the first draft of the map for humanity's future among the stars. Voyager's discovery gives us a new way to see the galaxy. Our sun's bubble isn't unique. Most stars create their own, forming a cosmic foam of interacting bubbles. The Milky Way isn't a uniform sea, but a collection of stellar bubbles, each with its own frontier. Crossing from one bubble to another means passing through turbulent, superheated boundaries. This bubbly model explains cosmic ray variations and the structure of interstellar gas. The pressure from these bubbles can trigger the birth of new stars and planets. Our wall of fire is just one example of a universal process shaping galaxies. We now see the night sky as a dynamic ecosystem of bubbles, not isolated stars. Voyager has given us our first glimpse of this intricate structure. We are part of a living, breathing galaxy, connected in ways we never imagined. The Voyager journey mirrors our own, from home into the unknown, driven by curiosity. Along the way, we find wonders like a 90,000-degree wall of fire that reshape our understanding. The Voyagers, now silent, have traveled farther than anything we've built. They carry our music, languages, and hope into the galaxy, a message in a bottle for the cosmos. Their discoveries are milestones in humanity's quest for knowledge. The universe constantly challenges us, inviting bigger questions. The heliopause's true nature is a reminder. Every answer leads to new mysteries. We keep looking up, building new probes, dreaming of new worlds. The Voyagers have shown us the way, across the threshold, into the vast, strange universe. Their story is our story, a curious species, living in a bubble, always wondering what's next.